Hi guys, welcome to another lecture of Stats for Data Science course, right? So till now we discussed about IQR, EDA and data, what is data, right? We discussed about outliers, what is meant by outliers, right? So now we are going to discuss about a very important part, that is specific multiplier, right? Remember that in the last lecture we discussed that what is the formula for Q1 and Q3, that are the upper bound and lower bound types of outliers. So here you can see that in the formula when I subtracted 1.5 into IQR, what is this 1.5? If you just have a look on this, what is this 1.5? Can you just see that? So this 1.5 is nothing but a specific multiplier that we use in the formula of the outliers when we calculate an outlier, right? What is a specific multiplier? What does that mean? Basically this is a less or more, right? Means if we have to calculate the outlier now, if you have to calculate the lower bound and upper bound outlier, you just have to subtract or you just have to plus something in the q1 and q3, that is the 25th and 75th percentile respectively, and you have to just subtract and add something in that, right? When you just subtract and add a quantity like 1.5, or you can take this quantity as 2, you can take this as 1, you can take this as 2.5. It depends on your, it depends on your just assumption, right? If you just assume that 1.5 is the, you can say 1.5 is the mostly used specific multiplier in this case, right? In, you can see in many calculations they are just using the 1.5 in this formula, right? So 1.5 is nothing but a specific multiplier, a value that adds on or subtracts from a percentile to just give you the answer of the outlier, right? So it is a specific multiplier. So let us now discuss about the EDA. In the last lecture also we discussed that EDA is good for data visualization. It is good for data interpretation. It just identifies the kind of data that is good for data, that is good for interpretation, right? Interpretation, you can just see that we made the graphs from that, right? So we are just learning about the theory of this, that how we can make the graph. You can just remember from this theory that EDA is the only tool that is used to visualize the data, right? If I say you that you have to, this is the data and make a scatter plot, make a box plot from that, so you are going to use the EDA in that, and we will just do the coding also, how the EDA is used with the help of libraries like matplotlib, cbon, sns, right? So that I will also explain. So now come to the this type of data. You know that data is simply a collection of facts, figures such as numbers, words, measurements, observations, or just assumptions or description of some things, right? But if I say you that, it means if I say you that you went to an event and just give me the description of that particular event, just if you went to an event and you just give me the description of that particular event, you will just say that the event went good, right? We had this and this, but can you describe that event in a quantity? You cannot describe that event in a quantity, right? So that is the qualitative data. Means data is basically the description of a particular event. It can be numbers, it can be words. Means data is basically of two types. Either you can say the numbers or words or the measurements, and you can say the second type can be the description. So from that we came to know that the data is having two types, that is the qualitative data and the quantitative data, right? Qualitative data has no range at all. You cannot tell that the data has a maximum or minimum value, right? That is the quality of the data, that the data is good or bad for the interpretation, right? But when we come to the quantitative data, it has a particular range. When I say that the data has a range, so you can easily tell me that the data is quantitative data, right? So there is basically the difference between this, right? So there is basically the difference between the qualitative and the quantitative data, right? So here you can see that quantitative data is only the descriptive information of a particular event. Means it describes something, right? If I say that describe me an event or describe me a particular data, just interpret it and describe me how is the data, is it effective or not. So you can say that the data is qualitative, right? But when you come to the quantitative data, that is the numerical information. When you just measure a particular data, the maximum and minimum values, then you can say that it is basically the numerical information information, and the quantitative data, the numerical information, is also having two types further, that is the discrete and continuous. This is the very important part in statistics, that the data, the quantitative data has two types, that is the discrete and continuous data, right? So what is meant by discrete data? Discrete means something that doesn't have any limit, doesn't have any unit, right? If you say that the data is having no unit at all, no unit is behind the data, so that it is basically the discrete data. It has some certain numbers that can only be counted, right? If you can just count, means that data is finite data. Finite is something that can be counted, na? So that the data is counted, so that the data will be known as the discrete data. For example, an array has a limited number of events, as it has a finite number of events, so that is a discrete data. But when you come to the continuous data, continuous is something that can be measured. It has units, but it cannot be counted, right? Discrete can be measured but not counted at all. For example, a table of values, where we just do the comparison and we are making a graph, right? There you cannot count the values, that is infinite, right? So continuous is something that has units, but it is measurable and infinite. Discrete is something that has no units, it is countable, it is not measurable at all, and it is finite, right? So this is basically the difference between the discrete and continuous data, right? So let's come to the another topic, that is the difference between sample and census, right? So what is meant by census and sample? What is the difference between sample and census data? So census is something that is a whole data, you can say a whole population. When I just say, for example, the best example can be taken as that is some people that are suffering with cancer, that is the whole population. Or you can say that a class, that in college or university there is a class, right, and that the students of the class is taken as a sample, is taken as a census, right? But when I say that select the students who have grade A plus, so the students who will be having grade A plus, they will be chosen as the sample. They are the part of the entire population, right? Another example can be taken as census means the people having cancer, right? But the sample will be taken as the people that are suffering with the blood cancer, right? If I say that any other cancer also can be taken here, so basically the people that are suffering with any other kind of cancer, they can be taken as the sample. So this is basically the difference between census and sample. You can just read this very important point written here also, that is a census is when we collect the data for every member of the group. It means the whole population, right? Here the data is collected for every member of the group, right? It is not like that you are just excluding some members or you're just including a particular type of members, right? Census is when you just extract the data from all the members of the group of the population, right? But sample is when we just collect the data for the selected members of the group. Here I have selected the people with who are just suffering with the blood cancer, right? So that is basically a sample. For example, if you just choose 120 people in your local football club, so that is basically a sample, right? You're just choosing the people with your football club, right? So that is basically the difference. Now comparing the data, the data has two types, that the quantitative and qualitative. So but when we just come to the comparison of data, so it is also having two types, that is basically the univariant and bivariant data. So that is basically the univariant and bivariant data. So uni means a single thing, and variant means something, the data which has variables, right? So univariant means the data which is having only one variable to describe, to compare with, right? Means in univariant you can say the comparison is less than the bivariant. Bivariant means the data that is having a comparison between two variables, right? For example, in univariant you just take one variable, you are just taking simple target variable, right? For example, there is a section of students and just I take the variable as the UID of the section, so that is basically the univariant, right? But when I say bivariant, there are two variables at all, where we do the comparison between those two variables only. So for example, weight or frequency. You can say height and weight. Height is also a variable and weight is also a variable, and when you just compare with the height and weight, you just make a graph, and particular graph seems like this. If I just replace the height with this and weight with this, so there is a particular graph made here. So that is the bivariant data. Another example can be taken as sales versus temperature. When I just you can say in a particular state or a country or a place, I just notice that what are the sales or what are the temperature, right? You can just take any other variables also, like, and you just compare these two, the data. You just made a table where you just do the difference the between the sales and the temperature, basically, right? I just write here sales and the temperature. I just noted some points that these much sales held at this temperature, this degree Celsius, right? So I just made a table of particular values of sales and temperature, and I just made a particular graph. This graph will be having a particular range, that is the difference between the maximum and minimum value, right? So this is basically a bivariant data, right? And what is the role of comparing the data? Why do we compare the data, right? So you know that in the data visualization we have to make the graphs like this scatter plot, box plot, you can say pie chart, and other graphs also. So basically in the scatter plot now we just have to compare the y and x axis, right? So basically comparing the data is used for these types of things, like the scatter plot, regression, outliers, right? For the minimum and maximum, here you can see that the range is having maximum and minimum value, right? So this is basically the scatter plot, and this is basically the function of comparing the data, right? So this is all about today's lecture, right? In next lecture we will also be going into deep, right? We will be discussing about the term outlier more into the depth, right? You know that outliers, these are the values that lie outside the data range, outside the other value, right? If I just make a graph here, that y-axis and x-axis, horizontal and vertical axis. So this is particular graph. If I just plot the values 1 2 3 4 5 6, right? So you can see that 1 to 5 numbers come in this range, but the 6 is just out of range, right? So 6 is basically the outlier here, right? Outlier is the, you can say, the value that is lying outside the range, right? We will be discussing this in the next lecture more into the depth, right? What is the outlier, right? And one more point you should remember, that the data is also known as datum, right? So data is also known as datum. These are the particular things that you must be remembering. So this is all about today's lecture. Thank you. Have a nice day.